Okay, sorry, my other video was cut a little short. I had some technical difficulties and lost sound. So I'm going to start about where I left off. I did remember, though, while I was paused and charging my phone up a little bit, that I did not cover with you how to read the codon chart. And that's because I have another video on YouTube that goes over specifically how to read a codon chart. Look at that video. It's pretty short, and it shows you exactly how to read the codon chart. All right, so I'm going to start about where I left off. So we're over here with messenger RNA, and it has attached to the ribosome. And so messenger RNA, the first codon is AUG, okay? I want you to read your codon chart. So AUG, what does it code for? That's right, it codes for methionine. But before you can put the amino acid in there, you have to have the translator come in. Because remember that messenger RNA does not speak the same language as ribosomal RNA. So a translator has to come in. The translator is called transfer RNA. And again, following Chargaff's base pairing rules, A matches U matches A, and G matches C. All right, this is the codon. This is its arch nemesis, or its opposite, so it's called a anticodon. Remember, you don't read the codon chart from the anticodon. You read it from the codons, and the codons are 3 consecutive bases on messenger RNA strands only. All right, so AUG, A with U with A, G with C. It codes for, when you read your codon chart, it codes for methionine, the amino acid methionine. So then the next thing that happens is the transfer RNA detaches and it just goes away. You don't have to know what happens there. You just need to know that it's not there. And the amino acid comes up here and starts building a polypeptide chain. Polypeptide chain. All right, so you've got methionine up here. So the next thing that happens, that is went away. The messenger RNA goes to the next codon, which is GGC. Somebody tell me, what does GGC code for? Look at your codon chart. GGC has the anticodon from tRNA of CCG. GGC codes for the amino acid. That's right, it's glycine. It codes for glycine. So it goes here, it's translated, and here is your amino acid. Okay, remember that the ribosome makes the amino acids, or makes the proteins. Recall from our unit on biomolecules that amino acids and proteins are synonymous. All right, so GGC codon codes for glycine. tRNA translates it through a process that's called translation. It translates it to the ribosome so that the amino acid glycine can be built. Amino acid glycine is built, so now the transfer RNA, it goes away, and the amino acid glycine comes up here. It joins the polypeptide chain. It is attached to the methionine by a bond. Recall that bonds hold things together. They're the glue that holds things together. So there's a bond between each amino acid, holding them together to build the chain. All right, so then that has been finished with the second one. So now we go to our third codon, AGU. Read your codon chart and tell me what AGU codes for. That's right, AGU codes for serine. So its translator comes in, and again, using the base pairing rule, A with U, G with C, U with A. If you've forgotten the base pairing rule, remember our saying at your grandma's crib. A with U, G with C. Okay, so A with U, G with C, and A is still with U and U is with A. Understand? All right, so what does it code for when you read your codon chart? It codes for serine, that's right. So it has built the amino acid serine. So what happens next? This moves over to the next codon. This goes away, and the amino acid serine comes up here and joins the polypeptide chain. A bond forms in between the two so that it can make the chain. All right, so our next one, our next codon is GUC. Read your codon chart for GUC. GUC has the anticodon of what? That's right. Its anticodon is CAG. How did you know that? That's correct. You know that because of the base pairing rule at your grandma's crib. A with U, G with C. At your grandma's crib is just a mnemonic. It is not the base pairing rule. The base pairing rule, remember, is A with U or A equals U, G with C or G equals C. Got it? Which is adenine with uracil, guanine with cytosine. All right, so GUC has the anticodon of CAG. CAG is your translator, or tRNA. It translates GUC to the ribosomal RNA. And what is the amino acid that GUC makes? That is correct. It makes valine. All right, so then what happens next? That's correct. The messenger RNA moves over to the last codon. Okay, so I want you to read your codon chart. UAA. What is its anticodon? Oh, it doesn't have an anticodon. Why does it not have an anticodon? That is correct. Whenever you read the UAA on the codon chart, it says stop. So that tells you that after valine, and I forgot to put my valine up here, after valine, the UAA is the stop codon. And so when you come to any of the stop codons, there's 3 stop codons. When you come to any of the stop codons, the polypeptide is now complete. And what happens is this chain comes here and it moves from the area of the cytoplasm to the Golgi apparatus. Remember that the Golgi apparatus is the UPS of the cell. Remember that what UPS does? It packages things, right? Wait a minute, got that wrong. It receives things first. It has to receive it before it packages it. Then it packages things. And then UPS will ship it out. Well, what does the UPS of the cell do, the Golgi apparatus. It receives proteins, then it packages the protein, and then it ships that protein out of the cell, out of the cell membrane, and if this would represented the cell membrane, it would go out of the cell membrane. This is a complete protein that's going to go out to a part of the body, and it's going to perform its function for the body that particular amino acid would perform, or that particular protein would perform. Okay. One last thing before I check out of here. I'm going to go ahead and remind you how to read a codon chart, just in case you can't seem to find the video on how to read a codon chart, because it's very important. You do not want to miss this question on the EOC. This is one of the easiest questions on the EOC that you can ever get, and it is always on the end of course test, and of course it is on your unit test as well. So I'm going to go ahead and remind you how to read that codon chart. All right, I'm going to show you two codon charts. The first one is a table. This is the one that I'm 99% sure that they will use. All right. So the first letter, if it's AUG, you go to first letter A. Second letter, U. So A and U line up at these four amino acids: isoleucine, 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 methionine. Okay? So if the third letter is G, A, U, then go over here to G, and they all three meet at methionine. Methionine is two things, or AUG is two things. AUG is either the start codon, which is the start of the amino acid, but it's also methionine. So it codes for methionine. It can be a start codon. So what you need to know about that with messenger RNA is that polypeptide chain only starts one time, okay? So you can have AUG numerous times in the messenger RNA. The messenger RNA can be not the messenger RNA. The polypeptide chain can be 3 amino acids. It can be 4 amino acids. It can be 20 amino acids. It just depends on which protein that it's actually building for what body function that it's going to be performing. Okay? All right, so that's how to read the chart. And that's my little story about protein synthesis. So it should help to prepare you for our test.